Howdy again, Mr. Pete, your interweb shop teacher, and this is tips number 829. It's very essential that you watch the previous tips number 828 because this is a two-part video. Otherwise you won't know what I'm talking about at all. But this series of videos is all about slowing down a wood cutting bandsaw and turning it into a metal cutting saw with a speed reducer from Sears Craftsman and changing the blade. And I posed several questions, and to start with, I'm going to explain all about how you determine the actual blade speed in feet per minute, not RPM. And the answer, if you're waiting for the answer and you did the calculations yourself, is 258 feet per minute is the speed with the Sears speed control on there, speed converter. So looking down below, there is the Craftsman speed converter. I talked a lot about it. There's also several videos under my what is it, or rather what makes it work. Now this has been a failure so far. 258 feet per minute is way too fast for metal cutting. I need to cut it in about half. Ideally it needs to be about 100 feet per minute. But before we get into all of that and some explanations and demonstrations, let's talk about how I actually arrived at that answer of 258 feet per minute. There are three ways of doing it. One is to look it up on the internet under speed calculator. I'll show you that. Then you can do it mathematically, and finally you can do it with all kinds of test instruments and tachometers and surface feet per minute measuring devices. Now you won't have any of that. I'm just going to show that for the heck of it, and I've done that in other videos as well. In part one of this video, I challenged viewers to 2 extra credit questions, and I will give you the answer at the end of this video. But the first one was, what is the purpose of this little tapered pin that is used on all Delta bandsaws and maybe other brands as well, that is meant to be put into the hole in this slot? What is the purpose? And secondly, I posed this question. This is a hand reamer, this is a power reamer, 5/8, but why is it that a hand reamer cannot be used to ream a blind hole, but a power reamer can? But of course I had to turn it by hand, putting a wrench on the tang, not just a breakfast drink. Okay, in the last video I gave you all of this information here that is necessary to calculate cutting speed in feet per minute. So remember that the motor speed is 1725. That speed reducer that I showed you is a 10.24 to 1 ratio. So the pulley on the reducer is 2.5 diameter. The pulley on the saw is 6 inch. And the bandsaw wheels are 14 inches, and the answer is 258.3. And let me show you the formulas that allow you to achieve that answer. Raise your hand if you got it correct. Wow, quite a few hands went up. I found these formulas on the interweb here, and there's 2 different ones. Actually, they end up being pretty much the same, but I'll show you both. The formula to determine feet per minute is motor RPM multiplied by the motor pulley diameter divided by the driven pulley diameter times the bandsaw wheel diameter times pi divided by 12 equals surface feet per minute. Is that clear as mud? And here's another one that is about the same, and I found that under www.newwoodworker.com. Write that down if you need to. This is a screenshot of the formulas. I found that on the newwoodworker.com website. Thank you to them. Okay, this is what it looks like as a formula. And looking down here, I plugged in the numbers, so it's 168, that's the RPM, times 0.21, that's the pulley diameter, but we cannot express it in inches. We have to have decimal part of a foot, so that's 0.21 of a foot, over 0.5, which is half a foot on the saw pulley, 6 inches, And over here, the 1.166 is the wheel diameter, 14 inches, times pi, and that's over 1, because 1 is a full foot rather than inches. And then multiplied out and simplified, it's 70.56 times 3.66 equals 258. So there's your answer, and that's how it is done mathematically. Now, I know a lot of you do not like math, so let's take a look at the next method, and that is to look on the interweb at Keith Rucker's Vintage Machinery site, and he's got a nice little deal there where you just plug in the numbers. Let's take a look. I have to go up to the computer for that. This is actually the easiest and best method of doing it, especially if you do not like math. Go to Vintage Machinery. Thank you, Keith, for this, and plug in the numbers. 168 is the RPM of the motor after it goes through the speed reducer. That pulley is 2.5. The wheel pulley on the bandsaw is 6 inches, and the diameter of the wheels are 14. Click on calculate, and there's the answer in red, 256 feet per minute. Now, that is way too fast. I already told you that, so let me change this 6 to 12 if I put a larger pulley on, and I do have one. I'm not sure I will do that, but this is just going to cut it in half. So now it's 128. So the 12-inch pulley would make it feasible to use this saw for metal cutting. All right, let's go down and do the third method with all of the paraphernalia, which you probably do not have, but might find interesting. The easiest way with instruments to check feet per minute is with this type of tachometer, but these are rather pricey, and you have to have the wheel attachment, which just slides on there. And I'll be using the red dial in there for feet per minute. Black is for RPM. So here we go. And I don't know why it takes so long for it to get up to its final speed there on the dial. And I'm not sure that this thing is working right, but you can see there that I'm at almost 250 feet per minute, and then you can drop it back down. I wonder about the accuracy of this. And of course you can use your Starrett speed indicator, RPM checker, whatever you call these things, but you have to have the correct little attachment from Starrett. This is not the correct one, and it clips on there. It was sold as an accessory and then can be used to calculate by reading the little dial right here. In order to check the speed of a wheel like this or a pulley, the venerable Stuart Warner tachometer does not work well at slow speeds. Be careful of those belts. So this is out. You can use your Starrett or other type of indicator. I wonder what I paid for that. Oh, $10. But you need your pocket watch or your phone or your wristwatch or something to use that right in the center hole, but it works well. And of course you can use this. There's another tip. There's a whole bunch of tips that fit on this. And you know what? This pulley is running slow enough to where you could actually count the revolutions. That's why I put the blue tape on there and count them for exactly 1 minute using your stopwatch. And you can use your Chinesium tachometer. Notice I put a little piece of reflective tape on it. And that's showing about 71 RPM. Now I know I've told you too much there, but that is the way of determining the speeds of pulleys and wheels. I believe I did this little demonstration in part 1, but I'll do it again. Turning the machine on. This is 1/2-inch thick aluminum. And there's a lot of vibration and chattering there, even on aluminum, but of course that's not the right blade for aluminum. I would need the wood cutting blade or a skip tooth blade, and I'm sure it would work just great on aluminum, but I'm not going to change blades to demonstrate that, because at this point I'm extremely discouraged by the high speed that we're getting with this speed converter. I thought it would bring it down to about 100 because that's, I think, what Sears is claiming. Well, they didn't tell the feet per minute. They just said it would slow the bandsaw down. But the Sears Craftsman bandsaw has a 12-inch wheel. The Delta is a 14-inch wheel, and there's a difference there in the final speed. So looking back in the catalog, Sears doesn't tell you the feet per minute. I already said that, I know, but so we're not sure what they were claiming, other than it did slow the motor down. So at this point I am extremely discouraged, and there's really a couple ways of doing this now, but let's talk about a larger pulley. But before I do that, I know that there are going to be people that say, well, use a variable frequency drive, or use a DC motor, and all kinds of motor controls, and that was all covered in several of my videos 3 or 4 or 5 years ago. You can go back and look at that, and I wasn't real satisfied with any of those methods either. Although some people have had great success using treadmill motors. Again, this is a 6-inch pulley. This is a 12-inch pulley that I had in stock from my other failures. However, I need a different belt. And then the other problem, even if this was on, I would have to slot this right here on each side for the belt, because the belt would come out much farther, probably about out to here. Furthermore, if I did that, naturally this guard isn't going to fit anymore. I'd have to fabricate a much larger one, similar to this Amazon box in size. So it's about 12 inches right here, and I forgot what the height is. This is a little higher probably than what I need, but essentially I would have to have a guard on it that size, but made out of sheet metal. As I said, this project is a bit of a failure because I didn't achieve the slow speed, but if I was going to use it the way it is now, I would have to put the guards on this for safety and to keep the chips out of it. And of course, a guard up here again, always thinking about safety. And how did they do it on other saws that are commercially made? Well, see, the reason I'm kind of quitting on this is I already have 2 vertical saws for metal cutting. And this is the wood cutting one. I sold one other one rather recently. But I don't really need this saw. I was just doing it as a project because I found this wonderful Sears speed converter, which I've talked about here way too much. Furthermore, in my travels and of all the videos that I watch on YouTube, hardly anyone has or uses a vertical bandsaw other than Keith Rucker and Adam and a few people that have big commercial bandsaws. Typically they don't have these smaller ones. And what they're doing is they're using cut-off wheels and off-hand grinders and all kinds of other ways. They have a lot of horizontal saws I see on YouTube, but really not these. So I'm not preaching to the choir here. I don't think anybody cares, but I want to show you something on my Boyce Crane bandsaw, which is convertible between wood and metal. It's from the 1940s, but I want to show you the kind of gearbox they used on it for reducing, and it's probably a 50-pound gearbox with oil in it. Okay, this is my 14-inch Boyce Crane. Well, it's about my age. It's almost 80 years old. I used to have Bakelite wheels, and they cracked, so I put aluminum wheels on. But it's set for slow speed, about 100 feet per minute. Now I'm going to pull this out from the wall, turn it around, and we'll take a close-up view of that gearbox if anyone's interested. I am. I'm interested in everything. Okay, here's the back side of the machine, and I took the door off for demonstration purposes here. The motor's down there, and you communists that are worried about the electrical code, don't say a thing, I know. But the gearbox is up on top behind this big aluminum step pulley. There used to be a step pulley down at the bottom, but I had to take that off because I changed the motor. There was a Chinese motor that lasted about 6 months that I put on there. Had to throw it away, and I put US made big old motor on there. It works great. Don't worry, I've got this thing unplugged. Now again, there's 3 steps here, and I'm on the middle step of this aluminum pulley. And this is the gearbox, cast iron. It has a couple leaks on it, but I don't really care. So if I wanted to change it from slow to fast, I would bring this tumbler down into that position, and then this knob here has to be in, and I need another hand to do that. I don't know if it's going to click in or not. No, I need another hand to do that, and I'm holding a light with the hand, but that's how it works. I want to bring that back out, and I've had this since December of '93. It's really been a good saw. I don't think this thing will wear out, but that's the way they made things years ago. But this was probably not available, or affordable, I should say, to the home machinist. But this saw was also available as a straight woodworker saw, without the gearbox, which would have run much faster. So anyway, this is 2-speed times 3. It would have been 6 speeds altogether. 3 for woodworking and 3 slow ones for metalworking. All right, enough of the Boyce crane, but this is really a very good saw, even though it's ancient. Okay, it's 3 days later, and I had become very discouraged, as it is my wont to do, because I could not get the speed low enough. But after sleeping on it for 2 nights, I decided that I'm going to forge ahead, and I put that very large 12-inch pulley onto the saw, and then I had to buy a new belt, and it cost $10.49. You know, I've got hundreds of belts in stock, but the largest that I had was a 64. Would you believe that? And I spent 15 minutes out of my life trying to find it. So I just went down to Ace Hardware and I broke down, and so this is what I came up with here. And notice the differences here. I do have the guard over the speed reducer. And remember, I told you that in order to use the large pulley that I would have to slot out the sheet metal to accommodate the blade, the belt rather. So I didn't want to do that, because in 25 years somebody's going to work on this and say, who's the bubba that took a hacksaw to the... Anyway, so I put these pieces of round tubing on there to kind of act as a... Now, I know there's a lot of friction. I know all of that. But that's what I could come up with quickly without being too painful. But what have I done by that? I cut the speed down by 50% by doubling the size of that pulley. So by changing the pulley, I have reduced the 258 feet per minute into half of that, which is 129 feet per minute. Now the target speed was around 100, so I'm a little over that, but really this is close enough to demonstrate everything that I really wanted to show you. So let me turn the saw around. I know there's no belt guard, and I don't intend to do that, because when this video is over, this is a bit of a failure, let's face it. I will change this or convert the saw back to its original configuration for wood cutting, because I have 2 other vertical metal cutting bandsaws, plus that Porter cable or whatever it is, power bandsaw, hand bandsaw. I have converted that into a little table model as well. So I got plenty of saws. I do not need this one, but I need a wood cutting. So this is my wood cutting saw. So before I turn the machine around to actually make a cut, I thought you would like to see this. And that works just fine. I realize that it's a power robber and it's a friction maker, but we don't care, do we? That brand new belt is still pretty stiff. Alright, here's a test at 129 feet per minute. This is still a piece of 1/2-inch aluminum, and the blade 3/8 wide, 18 teeth. I know it's a bit fine, but I'm going to tell you right now, it's no better than it was before, even though I slowed the speed in half. Watch this. Now it's cutting, but it's chattering like crazy, and you might even be able to see the chatter marks in there. I guess you can't, but it's really not usable at all as it is. Let's try some steel. This is 1/8 inch thick mild steel. Now it cut fine, but it's chattering like crazy. Now this is 1/4 inch thick cold roll steel. Now that's just horrible chatter and vibration. It does the job, it cuts, but I don't like it at all compared to my good metal cutting bandsaws. So I am considering this conversion to be a failure, not so much for the SEARS speed reducer, but for the saw itself. Let me explain. About 50 years ago, my brother owned a Delta saw, and it was the convertible type, and there was a label right here that said something like this, wood metal, and it had the gearbox on the back side that you could shift from wood cutting to metal cutting very quickly compared to what I have here. But Jan only owned that saw for a few months. He absolutely hated it because he said that it vibrated and it was nothing like using a Grobe or a Dual or a quality saw. So he dumped the thing almost right away because he was used to good saws. So I believe that this type of saw, since it was designed for wood cutting, does not have the rigidity required to prevent chatter and vibration. Now I invite you engineers and you people that are a lot smarter than me to explain that if I am wrong or otherwise. So why is it? It has to be in the frame. Now notice that in the Delta, let me close up on that. Years ago, the Delta bandsaws did not have a flat back pattern like this. It was a casting made with a core in there, so it was a hollow casting, and I believe it was far more rigid, and they probably did this to cheapen it because they didn't need a core. That would cut the cost way down in manufacturing, essentially eliminating the possibility of using it for metal cutting. But look at here, we just got one bolt holding that on. Maybe that's good enough. I don't know. I'm just trying to pick this apart and determine what is the cause that is preventing this machine from being used as a metal cutter. Off camera several days ago, I was still trying to troubleshoot this, so I took this screw jack and I put it under here and I put some pressure on this, and then I took several trial cuts thinking that the entire arm here is vibrating like a tuning fork. But to be honest with you, this didn't make any difference at all, so I believe that I was delusional, as it is often my wont to be. Well, I beat this subject to death and I made a two-part video on it, and this is very similar to what I did several years ago, and I had the same problem then, so I don't believe it was even probably the other speed reducers that I used 5 years ago. It's all about either the blade or just a lack of rigidity in the machine. So at this point, I'm just giving up because I don't really need this. Again, I was just showcasing that slow speed converter, which I think really is a very neat device. Make sure you watch all of those videos if you like this type of thing. And stand by now for answers to the extra credit and tons of still pictures. I hope you liked the video, even though it was, again, a bit of an abject failure. And I'm glad I can laugh about it. Hope you did too, and I'll see you in future videos, I hope. In part 1, I posed a little bonus extra credit question as to what this pin is that goes right here into the bandsaw table. Delta tables all have this, maybe others do as well, I don't know. But cleaning this off real well and using a Brown and Sharpe straight edge, let me illustrate the purpose. Now, when they cast the table, if they do not season the castings or stress relieve them, what happens here is they machine this surface here and this slot and various parts underneath the table. Then they put this slot in there, and that causes there to be some misalignment as the stresses take their toll on the casting. So if I can demonstrate that right here with the pin out, and this is a 3,000th feeler gauge sterret, not that it matters. I am pressing down on this part of the table, not over here. So watch this. 3,000ths, and it moves, it stops right about there. Now watch what happens when I put the pin in. And it doesn't do any good just to put it in like that. You have to tap it in, which is a pain because later when you want to remove it, you got to use either a wrench or your Bernard or something like that. But watch the difference now when I do the same little experiment here. The feeler gauge is tighter than a bull's hind end in blowfly season now, so I have removed that little bit of warping. That's the purpose. That was a waste of time, wasn't it? Who cares? And does it matter on a wood cutting bandsaw? Probably not at all. Okay, here is the answer of why you cannot use a hand reamer to ream a blind hole if you expect it to be the exact diameter at the bottom of the hole. And the reason is that, first of all, I should say that power reamers, whether they're taper shank or chucking reamers, are pretty much the full diameter right out to the end where the chamfer is, whereas hand reamers are tapered on perhaps the first ½ inch. It probably varies with length. So when we get back into this area, this is a 5/8 reamer. It truly is 0.625, but if I measure it out here, which I will attempt to do, it's kind of difficult to mic reamers. But you see the diameter there is considerably under 5/8. What is it? It's 6/16. And the reason for that is it helps you get it started. That's why they're tapered. But because of the taper, you can't really get the diameter you want at the bottom of the hole with a hand reamer. You got to use one of these. Here's a little extra credit. Who made Powercraft tools? You're right, Monkey Ward.